Hello and welcome to TidyX episode 136. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
My name's Patrick Ward. Thanks for tuning in to TidyX. As always, if you enjoy the work that we do, we do have a Patreon page. We're always grateful for anything that you would like to donate if you feel like we've helped you out. And remember, as we go through this, if you're enjoying this, like and subscribe on the YouTube channel. Drop your comments and questions down below. That's a great way to get in touch with us and make sure that your questions get answered on one of our upcoming screencasts. Like today's question, what are we talking about today, Ellis?
Today we're talking about fuzzy joins. And so we talked a little bit about fuzzy joins a few episodes ago in 136. So we're going to give a quick little update, recap of that before we jump into the question that we got here. So everyone's, caught up to date. If you want to watch episode 132 to get the full description of what's going on with that, go ahead and check that out. So let's load first some libraries. So tidyverse for our data manipulation needs, and fuzzy join, which is a great package that helps us do fuzzy joining pretty quickly. So in episode 132, we covered fuzzy joining of strings. And so oftentimes if you're working with string data, especially manually entered string data, people have typos. People mess things up. That's just life. Or you're dealing with a like player names and whatnot, where people have slightly different spellings of names, or they have dots in their names in some way. Sometimes it's entered versus not. So the way that you can go about solving that, let's pretend we've got these two tibbles here. So we've got this first tribble, which has somebody's first name, some score they got, and the rep that it was measured with. So Cody had 1 rep at 38. Jack had 2 reps, giving a 35 and a 43. But the second time Jack's name got entered, somebody had a typo and wrote the K before the C. So they typed that up, but we know that's the same person. And then Anna got a 45 on her first rep, so she crushed it. But then we have the second data set, and the second data set has their first name and their last name. And so that way we can create a full data set of all their information. And so if you were to just do like a normal left join from tidyverse, for example, if you do the left join, combining name by first name, Cody will match up, Jack will match up, but Anna won't match up because her name is capitalized, and the second entry for Jack won't match because it's misspelled.
There's no
So
one in
how
it.
do you solve that sort of thing, right? And that's where fuzzy joins come into play. So fuzzy join allows you to specify a string distance, which is the maximum amount of distance you're allowing these strings to be different, but still consider them to be equivalent. So fuzzy join comes with a handy dandy function called string dist left join. It calculates the string distance between the two strings, and then if they're close enough within a maximum distance, it'll say, close enough, and join them in. And so we can run this here where we're joining dat1 with dat2. We're saying join the name by first name. So name is in dat1 and first name is in dat2. And we're saying the maximum difference they can have is 3, which is calculated using the string dist function. It's basically how many different letters are there and a variety of other things that I'm not going to go into. We touch a little bit on that in episode 132. And we've already talked about this for a number of minutes. So as you can see, we join based on where Jack, even though it's misspelled, is able to add Jack. Anna, even though it's capitalized difference, is able to merge in as well. And that's like a very quick, high-level introduction to these fuzzy joins here with strings. We got a question from one of our viewers in our latest video asking about how do you do this with dates. So the question they posed was, hey, I've got these two tables. One is subject IDs, so we know how we can join on subject or player ID or however you want to say this, a unique ID for a person. And then they've got a sample date that could range from 1 to 30 times, so they could measure multiple times. And then the second one that has events data. And what they want to do, the way that I interpreted this, is they wanted to join on the closest event data to this sample within 21 days. Now, Manny, we love the question here. If I interpreted that wrong, give us a comment down below and give us a data set that we can work from. And we're happy to go over this again and talk through the actual answer if we're
Yeah.
misinterpreting this.
Just like we did above, just make a simple little, few lines, examples of what you got. And sometimes reading these questions without someone giving the explicit example, we botch this up because we create a data set that we think is what we're being described, and it's never exact. And then, so
Then we're off. So let us know if we don't answer your question, but we think we are, question mark. So basically, I wanted to go through how you might be able to approach joining in the some different time date information here and how you might go approaching that. So I wanted to step through the kind of the logic to build up a function and show how you might apply that function.
Mhm.
So first we're going to create two vectors of dates using the asDate function. One is going to be January 3rd, which is our reference date, and that's going to be called date1. And then we've got a vector of dates that are surrounding that. So from December 30th all the way up to the 7th of January. But note, none of them are the specific date of January 3rd as well. So we can't just do an equals equals and just join on matching. We want to find what is the closest date to January 3rd, given these dates here. So let's run that. Patrick, do you want to take us through one approach?
Yeah. So there's basically, before we get into turning this into something that's usable and operational for a larger data set, it's always helpful whenever you're building up functions like this to kind of work through the component parts and the functions within the functions that you're making to understand what's there. And so we're going to use this handy dandy function called difftime, which I believe is from base R. It's from base R. And basically all you do is you feed it two dates, or in this case, two date strings, and you specify the units of the difference that you're looking for. So in this case, we're basically saying, hey, take string date2 and take string date1 and calculate the difference in days between them. And since date1 is only a string of one value, it's going to create a vector of the differences between date1's value and all of the values in date2. So we get returned this vector that says the count of days between date1 and all of the dates in the string of date2. So everything basically from -4 up to +4, -4, -3, -1, 2, 3, and 4. And if we then want to extend that and say, well, what about the closest day? Closest, I think we need a T there, date. So for that, we're going to first find the smallest dist within the minimum distance. So we just created this time distance vector, which is the negative to positive values that are telling us our difference. And since the closest day is irrespective of days that happened before or after the date of interest, we're just going to find the minimum of the absolute time distance, which when we run that, is
that's
going
what the absolute
to
look like. Absolute removes the negatives, basically.
Yeah, get rid of the negatives, right? And then when we run that, we're going to get a difference of 1 day. That was the minimum. And then all we're going to do now is use a little bit of vector notation here. And we're going to say, hey, take date string 2, which is all those strings of dates. And the which function tells us which value within that vector meets the desired condition that we've applied. So in this case, we're saying grab the absolute of distance time, of time dist, so making all of the values absolute, and make sure that whatever value of absolute time dist is equal to the smallest distance, which was 1 day. Tell us which value within that vector string it is. And in this case, it's number 3. So if we were to run date2 again, the date2 vector, we'd count over 3, and there it is, and that's exactly what we pulled out by using by wrapping the which function, the which condition, within the brackets for date2 within that vector.
Cool. So now we know absolutely January 2nd was the closest date in this set that we could pick from to the reference date.
Yeah.
Okay, but that isn't dates usually, direction usually matters. Do you want something newer than or older than? So let's find what is the date that is after the point of reference that we care about.
Mhm.
So then we have to add some conditions around this. So we're going to take the minimum of the time greater than 0, right? So time dist gives us, okay, so these were the dates before and these are the dates after. So I only want the dates that are after, and that means that we do the greater than or equal to 0. We subset time dist to keep those so that we only have the positive values. And then we take the minimum again to give us the smallest distance of the positive days is 2. So then which one of those is 2? This time we don't have to take the absolute because we only have positive values. Makes it really easy. So that is the 4th entry in time dist. So that would be the 4th entry in date 2, which is 1, 2, 3, 4, the 5th. So this is easy to read because I put them in chronological order, but if you had a larger vector, it'd be a lot easier or a lot more difficult to read.
Yeah. Mhm.
So then we apply this to the same logic we had before. Which of these time dist values is equal to the smallest positive value? Run that, the 5th. Perfect. Now we've got
Hey.
a way to look ahead, but what if we wanted to look
Yeah.
backwards and say, given this time, we want the closest date from this vector that already happened.
Yeah.
That gets a little bit more confusing.
Yeah. Similar rules apply though. You're going to start out with a similar looking condition here. So you're taking the absolute of time dist. So again, we're getting rid of the negatives, but we're only going to keep those values in the vector that are less than 0, those time dist values that are less than 0. So we're going to get negative, or we're going to get 4, 3, and 1, but we're going to see them as positives right now because we're taking the absolute. Yeah. So that gives us a small dist. And now there we have the time difference of 1 day, which absolute time dist is equal to the smallest dist. And the time distance has to be less than or equal to 0 because, again, we care about days that happen previous to whatever event it is that we are interested in. And in this case, it's going to be the 3rd value within that vector. So if we go back to date vector 2 and we run this, that value is going to produce January 2nd of 2023.
So these seem relatively trivial, but that's because we have a simple data set. We know the answer to it, which is why we're building up our logic in this way.
Yep.
But so far, we've also assumed that we don't have a minimum or a maximum distance that the time could be away. We've said, hey, as far as the time scale goes, as long as we have a value, don't care, give us that value. But what if we did have a time constraint? So what if we wanted to have only dates that were within 2 days of our reference point? Because maybe we've got a measurement where it's very, very time sensitive, where we don't want it to be adding values that were more than a couple days away. So then we have to add a tolerance to this. So before we were just doing anything, any date. Now we're going to limit it to be within the tolerance. So we're going to say a tolerance of 2 days. We have to convert it into a diff time because those are the units that we're working with before from time dist. Now we're going to do the same sort of logic as before, but rather than doing a less than and equal to the actual value, we're going to say take the absolute and anything that is within that tolerance of 2 days, keep those. Again, do the absolute of the distance of those remaining values and calculate the minimum of that. So that is going to find the minimum difference within the dates that are within the tolerance. Mm-hmm. Say that a couple times fast.
Right.
So again, we get 1 day.
Yep.
Apply the same sort of logic as before, where we get the smallest distance and is within the tolerance.
Yeah.
And we get the 3rd entry, again, January 3rd or January 2nd. Boom, there you go. So we've built up the different cases that we might be looking for.
And just to just to sort of, before we put this in a function, talk through the reason why we keep using absolute of time dist to get rid of the negatives is because it just saves us code. If we didn't do that, we'd have to use the vertical bar, and it'd have to be like an or type of thing where is it or less than this or less than negative this value or positive this value. It just saves you code if you convert everything to absolute and then work from there.
So you'd have to do like tolerance or time
Or yeah,
dist
that
greater
gets
than negative tolerance.
yeah, it like gets ugly pretty
You have to
quick,
like
and
start thinking
so
about things weird. If you're
yeah,
just looking on in both directions, just take the absolute.
just do
It's
the
a bit easier
absolute.
to there.
Super easy. Yeah.
Yeah. So now let's combine all of that into a function that we can then apply later on, because the great and beautiful thing about R is you not only can build up your scripts and build that up, but you can put it into a function so you don't have to think about it much more anymore and apply it a ton of different times. So I'm going to use some Roxygen notation here because it makes it nice for documentation purposes. And when you write functions, you should just generally do that. So we're going to add a title. So these are special comments, basically, saying this is a title, find the closest date given some set of constraints. We're going to say X is our reference date as a POSIX CT, a date or a character vector. Y is the reference of date options, again, as a POSIX CT, date or character vector. The direction is, okay, are we allowing dates that are only newer, only dates that are older, or do we not care and therefore it can be any date? And tall is the tolerance. So how far out are we allowing us to look? And so in Manny's suggestion there, I believe he put 21 days. So tall in here would be as diff time 21 days. But the default value is going to be infinity because we don't have a minimum tolerance that we want to be using.
Yeah.
So let's build up the function which closest date. So again, we have our X, our Y, our direction, and tall. We pass all the options that direction could be. And there's a trick in when you're writing functions in R that allows us to do that, but only allow users to specify a single value. And we set the default tolerance to be infinity days. We calculate the diff time between X and Y to give us that time dist function or value that we had before. We use match.arg to only allow our users to specify one of any older or newer using this line here. We check to see if tall is a diff time object, and if it isn't, it'll stop them and tell them, hey, you've got to pass me a diff time object. And now we're going to pass our conditions. And so if direction is older, which means any times that were before the time of reference, time dist less than 0, make a Boolean vector of time dist dir. If the direction is newer, so any times after the time of reference, so time dist greater than 0, greater than or equal to 0, make time dist dir. And if we don't care about any of those, this is going to be true all the time. So make a vector of length time dist that is all trues. For our tolerance, we take the absolute of time dist, and if it's less than or equal to tolerance, you're good to go. And so now we could apply conditions to this. And so if none of these are true, if there's no cases where this is true, return a vector of falses. We don't want those. Otherwise, calculate the minimum distance. So what is the minimum value of time dist that meets the criteria of it being older, newer, or any, and within the tolerance? Find that minimum value. And then apply that same logic that we did in the last situation where we had find the minimum distance. Or, excuse me, yeah. The absolute is equal to min dist, and it's in the correct direction, and it's got meets the tolerance requirements. So we kind of built up all that logic. Really fun to talk about there. So now we can go through and make sure this is going to give us the correct answers as we got before. So date 1, again, is January 3rd. Date 2 is those series of dates. We can even shuffle this around too. So let's
do like sample from date 2. and size equals length date 2, and then replace equals false. And then you'll just get some random shuffle of whatever. Yeah.
There we go.
Yeah.
So now it's in a random order as
Yeah.
it might happen. So now we can be confident that it's going to give us the right answer, right? So we take which is the absolute closest date between date 1 and date 2? January 2nd. Closest date that is after date 1. So which closest date, but direction is newer? The 5th. Closest date, but before date 1. So direction is older.
Second.
The 2nd. Closest date within 2 days. So this time tall is as diff time 2. Note we don't pass direction because we don't care about that. And then this is a case we didn't talk about before, but it's closest date to after date 1 that is within 1 day.
Mm-hmm.
Or excuse me, yeah, after day 1. So direction is newer and the tolerance is 1 day. If we run that, we get 0 because there were no dates that were within 1 day of date 1 from date 2. They were also after it because the closest date was the 5th. So now we know it works. So now we can go about and do some fuzzy matching. Patrick, do you want to take us through the setup for this?
Yeah, so let's create some data again. We'll use Tribble and we'll just type in some fake data. We'll pretend that this is weekly body weights in kilograms. So we've got a bunch of players on the team and we've got several dates of each week that they've been measured, as well as one NA there. And we'll just go ahead and run that and get a weekly data set. And then, take a look at it. Perfect. And now we got daily data. So this is, let's say, like we'll say that this is caloric intake. It's just going to be totally random. We have players that ate a moderate amount, a little amount, and a lot of amount in any sort of given week. And this data is going to be measured daily. So we've got data that's representing their body weights by the week. And we've got daily data that's representing their caloric intake. And we're looking to create a table or a new data table, a third data table that joins these together using the fuzzy date joining that we just talked about. So we take that daily data that we started with, and we just initially begin with this mutate here. So we're going to mutate this new variable we're going to call weekly dat, and we're going to use the map2 function. So the map2 function is taking 2 arguments, whereas regular map takes 1 value. Sorry, this is 2 values. So we have 2 values. We're taking the player. Remember, that's the player's, in this case, unique identifier, and the daily date, which is the daily date that they measured their calories. And then map2 or regular map, it takes its value and then it applies a function to that value. In this case, we're applying a function to the 2 values, and the function is reading in those 2 values in the order that we specified them first as arguments within our map2 function. So player is corresponding to player, and reference date, is corresponding to daily date of kilocalories. And within that function, now we take our weekly data, which is, remember, what we're trying to kind of join up, and we're filtering all the conditions where the player equals the player. So we're looking for just that individual player's data, and we're going to parse through our entire data set where all of the matches occur. We're going to filter using our which closest date function that we just created. We're going to filter on the reference date and the date. So the times when the reference date and that weekly date, or the reference date is the weekly date, and the date of their measurements of kilocalories, we're gonna look for the times where the direction is older within a tolerance of as diff week. So basically what we want to do is we're trying to identify the kilocalories for each player in a given week preceding their next body mass or body weight measurement on the scale, right? And then we just do the, we pipe in select minus players here because we don't need that redundancy in the column, it should be. And then this is going to give us a list. So yeah, if we run this now, we have, because the daily metric, remember, is measured daily, and the weekly measure is just measured once a week. What happens when this function goes through its arguments and it joins these things up? It says, well, you know what? Player one has like all of these measurements, but then their weekly data has only one measurement. So I'm just going to have to like wrap everything in a list because I don't know what the heck you want me to do. And so what we'll do is now we're going to unnest that list. So unnest is basically going to look at that list column. We're going to tell it which column is nested, and we're going to say, hey, just parse this out. So now within each week, we have this data set that says daily metric, and there we see the calories. And now we see the weekly metric, which is their actual body weight.
Body weight.
And so what we could actually do is we could then, like, if we were to extend this out, we could create a new column that takes that date column, and we could use like LuberDate and find out which week it happened. And then we could group by player and week and sum up all of their calories for that week and look at how weekly calories are, related to changes in body weight and all of those kinds of things. Really fill your boots with whatever analysis you want to do. But this is the steps that got us to the data set so that it could be prepared for that analysis.
Yeah, so the idea was like this was just to show you a dummy data set. We weren't given specific data to work off of, so I was just kind of ideating and coming up with it. But hopefully this kind of gets you a good chunk of the way towards being able to do these fuzzy joins with dates. If you can come up with a better way to do this, we'd love to hear that too. Leave a comment down below. We want to hear, we don't always have the best ideas, right? Or it's good to...
Rarely do we have the best ideas, actually. It's shaped by you.
Yeah, exactly. Like we're just figuring this out, and this is one way to solve it. It's not the way to solve it necessarily. So I always want to like impress on that. Like this is just a way.
Yeah.
So with that is how you can look at doing fuzzy joins in combination with dates and finding the closest date to match onto your data set. So this is like a one-to-one join rather than a one-to-multi join. So with that, I think that is episode 136. Thank you for joining us for this wonderful episode. As always, my name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick. At tidy_explained is where the screencast lives on Twitter. tidy.explained@gmail.com is where the screencast lives on Gmail. But of course, as you've heard, the best way to get in touch with us is go to that YouTube channel, like and subscribe, drop the comments and questions down below so we can get to those on the air. And as always, really love doing this. And if you feel like we've positively impacted your work and you'd like to donate, we do have a Patreon page. We're always super thankful for whatever you may give.
Thank you all so much. Keep on exploring your world.